Going to start teaching. Yeah.
Okay, great. I'm not sure if I can call it teaching, but so let's see if we can learn. Because
Cool.
teaching is one side, and the other side is learn. So teaching without learning is not teaching. Okay, so well, I'm glad that all of you made it. So we were running to the class so together. So just coming from a group meeting to here. All right. So maybe before we start, so maybe it would be great to know why are you here, what are your
Right, and they've answered that question before. So the thing we can test is whether they all tell the same story or they confabulate every time.
Yes, try to diversify. So if one of the stories is pointing in this direction, try to go in an orthogonal.
Right. Okay, we want to
Starting
start
from
over
here.
here. He looks deeply in thought, so yeah. Okay.
Hello, my name is Brandon. I'm in the second year of biochem, and I'm just interested in AI and like how it helps with improving medicine, and yeah.
That's why we're here. All right, great.
My name is James. I am also second year of biochem, and I'm taking this class for the same reason, just how AI can affect medicine, because I am hoping to get into medicine or dental in the future.
All right. Okay.
Hi, my name is Atmaja. I joined the class because I thought it was interesting, but now I'm interested in the law aspect of suing people. If anything goes wrong,
Okay.
how?
So
Funny.
That's a plan.
when AI fails.
Yeah.
Hi everyone, I'm Isla. I'm one of the TAs in the course, and I've been a TA for a couple years now, but honestly, I just like that every time I join the class, there's always something new going on. There's always something different, and I mean, that's what AI is all about. There's always changes, and there's always, so, I don't know, it's fun being here.
Well, a course about the future wouldn't be valid if it's always the same. Yeah.
Yeah, hello, my name is Dev, and I joined this course because I'm also interested in learning more about AI. Initially, it was just one of my friends told me about it, so I thought it would be cool to try something new. But yeah, my focus has changed since, so.
Hi, I'm Ruben, and when I grew up, I wanted to be an astronaut. I don't know if this course will help me get there, but I'm just very curious, and it's been very interesting so far.
Cool.
Hello, my name is Don. I'm also in my undergrad second year of biochemistry. I'm here because I have an interest in going into the field of dentistry in the future, hopefully, and how I can apply AI in that job if I do make it.
Great. All right. So thank you for diversifying your responses. So we're hearing a lot of interest, and that's all we want. So to tell just a few words about myself. So my background is in electrical engineering, and so I'm trained as an engineer that now does machine learning research with some applications in neuroscience, and if our colleagues or students have interest in applying AI to imaging in the medical domain and healthcare, I will never say no. So it's probably that's why I'm here. Okay, so today I would like to introduce you. You might have heard of the word called interpretability, to take a closer look what it means for AI, because we do see AI applications more and more in healthcare, in medicine, in science, and in law, and even though we do hear a lot of success stories, there are also a lot of failures. And in my opinion, and that's where also my research is, maybe if we were to take a closer look of interpreting them, or what does it even mean, so we might be able to, at least when next time we talk to our colleagues, we can be aware of the limitations that they may have related to their black box you don't understand, or you might be able to, when you hear about the tools that is being used to understand and AI in healthcare, so you might be able to say, aha, I have heard of this, and now I know what you're talking about, so that's why we're here. Okay, so I'm not aware how was the previous lectures here, so, but here we're gonna make things a little bit abstract intentionally, because we want to focus on the meaning of that interpretability word and to fully understand what they mean. Later on, that can be used in the context of medicine or healthcare. Okay, so but before that, maybe say a few good words. So I just, before coming here, tried to search online on Google. I searched like AI is transforming healthcare. Actually, I happened to find an article that was 7 ways AI is transforming. I was like, well, okay, it's not that, it's actually not that old, so it's 2025. I went through the article to see what it says, and they were saying AI can interpret brain scans, and how I could write it, they were saying a new AI software is twice as accurate. So I should tell you, engineers or machine learners like to talk about numbers like this. So we improve our system by this much, and they're not going to say when it fails, how much or where. So we like to say when they're performing. So it says it does quite of a good job on brain scans. I went through the article a little bit more, came another statement about AI can spot more bone fractures than humans can. Probably that is a little bit of exaggeration because they maybe tested on one particular data set, so maybe it worked for their example, but if you ask a doctor, they say, oh, of course we're gonna do much better. So these systems still are failing. So there is this tendency. So when we hear about AI in the news or in different places, that AI seem to work well, but when we come in practice, they are failing. So because maybe they only able to do it well in that control setting that we designed it to, that we learned it to. You can think about it, the brain scan statement might be that you collect all the scans that are available in Alberta, at the university in Edmonton, in Calgary, in Red Deer, and now we can do a good job for all the hospitals here, but you go take it to North Africa and it drastically failed because it learned patterns that maybe were not applicable or generalizable. So before you go into this thing of AI is magic, so think twice. So replace as accurate by think twice. Think twice. I searched another article, and it would be great actually indeed if we can have all these practical, because I would love to see that. So I would love to see that I give my data to an AI and it tells me in 20 years, in 10 years, in 5, what are my risks. So if they can do that reliably, if they can be a framework that I can trust as a user, as someone that are willing to plan their future vacations and plans, so it's better to be accurate, it's better to be trusted. Okay, so let me show you, before we actually get into the details, let me show you a video. So let's see if I can play it here on when we were to talk about AI. So what is the scale of these models that we talk about AI? So it's going to start from very small numbers, just to emphasize how complicated nowadays AI frameworks have come. So I actually forgot to open it here. It's going to show me unfortunately, it seems, okay, so, 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 okay, so it thinks I'm hungry, so let that go. Okay, so let's actually, like, maybe for, and it's a good stuff. So this started in like neural networks, and like it was on a paper 1950s. So it's the deep learning, and it's going to go through how large they have become in terms of sizes. So it's as if you're actually looking into these videos of planets that they show, that they start with small planets, go to Milky Way and all. So it resemble that. So a little bit about the boom of AI and machine learning. 2012, there was a framework that came that all of a sudden they could classify many different images from each other. So the boom of deep learning came in 2012. And then we got more and more, and you can already see they started with 20 parameters, 30, now it's like 61 million. You might have heard of the name transformers that are being used in modern AI that we want to use for medical healthcare application. ChatGPT, so the first version, GPT-1, so 117 million. Oh wow, we're going to the billion, and we're not even to the ChatGPT 5. 1.5 billion. I'm not going to play a video for the full hour, so it's going to end at some point, so we're getting close to that. It's 2020, so there might be 2 more. You can already see, like, the scale we're talking about, they're not even comparable to how large they are. So in 2022, 540 billion. So these parameters are showing the level of complexity of these AI frameworks that are being designed. So probably this video was for the time up to 2023. So there is one more model that came, I think, from China. So they made it smaller, and their DeepSeek, you might have heard of it. So while I'm talking, probably these models. Okay, I actually need to stop it. So that's not going to play forever. So while we're speaking, while we're talking here, another maybe ChatGPT is being trained. So, and there are 3. So I mean, what do you think about this scale? So did you ever thought about how large these AI models are? So. Maybe we knew they're complicated.
It's kind of hard to think about a trillion.
Yeah.
Like a trillion is like a very...
Yeah, how do they even, like if they were to have computers, memories, like are they going to fit here? So maybe that's why we want to go to Mars, right? So we store it there. But it's very large. And the reason I'm playing this is for the following. So these AI frameworks have become, at this point, even when they're small, too complicated for us to understand how they're really working. So this basically means accuracy of them is one problem. So you want to improve their accuracy to do a prediction, but their reliability for us to understand when they are failing. So, or at least to understand, so if you were to use it in law that tell you like you have to convict someone, you want to know on which of these feature characteristics of the data from that particular individual is relying that decision. So this is what is called in the literature of machine learning interpretability. So when I say interpretability, you can think about it as human interpretability. Sometimes we think about it algorithmically, sometimes we think about it from human. So, and in my opinion, it's an important aspect. So I collaborate with neuroscientists, and so they want to understand the brain. I like them to understand the brain. And they want to know how this AI is analyzing their data, because the prediction is not the job, but for them to understand what is in those neural activities that they basically capture from a human brain, capture from mice brain and such. So this understanding interests me at a personal level and as a career wise. Okay, so are we on the same page? So we're going to look at interpretability. All right. So should I talk about something else? So do you want to see something else? Okay, so let's go through interpretability. Okay. So to define it, I'm not a native speaker. So then let's actually go through what even interpret means. I looked online and it showed me the following word. To start with the phrase that says, interpret means to explain or to present in understandable terms. And I'm adding to human at the end because if we're doing that interpretability to AI, on AI, we want it to be understandable with respect of us. So I'm leaving with you one paper if you wanted to know where these ideas of interpretability came, feel free to take a look. It's not a technical paper, but it talks about why we need interpretability and a few more concepts that I'm going to introduce here. Okay, so maybe that dictionary definition wasn't enough. So let's take a look into what people are thinking about interpretability in psychology literature. Explanations may highlight an incompleteness. What does it mean? Can someone try to interpret why we are looking into this, to the psychology literature? Why we're touching on an incompleteness?
Well, I guess if you're trying to explain something, like if I have to explain something to a 5-year-old, I have to like condense it in a way so that the 5-year-old can understand. But in that process, there's some information that's lost in that translation. So if I have like interpretability of a neural net that's only like telling part of the story, like there's more to it. It's like hardly. It's incomplete.
Yeah, I mean, this is a good point. So that's actually one of the challenges of interpretability. Or maybe, so let's think about it if you are trying to interpret a machine. So you may try to understand it and you realize that, like this key is broken. So I just realized that, the logic is not right. So
maybe it's kind of like your idea, like if you're explaining to a kid, sometimes if you explain like an abstract concept to kids, sometimes they'll be like, oh, why is it like this? They keep asking questions. Maybe it's incomplete because the more you look into it, the more options it branches out into, and then the more you have to look at other stuff.
Yes, it brings more questions.
Mm-hmm.
So I think we're going to the right direction. So why this is important? Because if we were to set a few characteristics that is important for us. So we want to trust an AI. We want, for example, to follow certain privacy criteria. So we, for example, maybe our world is causal. We want it to be causal. You can put any word, any things that you desire to be here. So maybe you want it to be reliable, fair, and such and such. So if you were to interpret it, so maybe you interpret and that explanation tell you something about if the model is fair or not. So the more you open that black box and you take to understand it, maybe you realize that it's actually discriminating against a population. Maybe my model is able to diagnose if someone has a cancer or not for male much better than female. So if you can only know this if you were to really look into the characteristics of it. So from that perspective, if you really were to focus on understanding these models, it can shed lights on the limitations, and then after that you can go and improve those limitations. This is why I chose the interpretability as topic of today. Okay. All right. So let's even make it even more confusing for all of us, because I like to be confused. So why it's important to be confused? Because it's going to push you to search and to go and look for an answer. So I didn't fully understand what Bahareh said. Let me actually go and read that paper that was on the first page. So my opinion, an ideal talk is one that you understand 80% and not, but the rest 20% is homework. So take it this way. All right, so let's say that now we want to interpret AI. There are a few things. When we talk about interpretability, there are two key aspects. So forget about it's actually on the right. So one thing we want to know is how do the AI framework, they're coming to that decision they have made, so to understand how they're making a decision. So it's not telling you if they're making it based on a correct understanding or if their logic is proper and is ethical. So it's only telling you, like, tell me how you make your decision. I want to know. Maybe your logic is broken. Another one, in terms of interpreting, is a word. You don't need to know the details, but I'm putting these words for you to understand. Nowadays, a lot of people talk about, we have a world, these AI models are being trained, so what they have understood about our world. So they may have an internal world model in them. So can we go and understand what they have captured and understood about our world? So generally speaking, you can think about they have an internal world model. Even if you were to talk about brain to neuroscientists, so a lot of them thinking about that we have an internal world model about an internal model in our brain about how the world look like. That's why probably even if you were to sit in the darkness and you still can see someone and recognize it even if it's very dark. Okay, so, and maybe an example word model, thinking about it that we have Newtonian's law, planets are moving around, the Earth is moving around the sun. So can an AI recover these laws? So can they understand actually these Newtonians, like physical laws or chemical laws or biological laws? Can they really understand them? Can they derive them from these data that they're seeing? Okay, so that interpretability and world models, so think about to understand what they've done. So let's say we did those two tasks and we fully interpret them. Are we done? It's slide number 6, and I don't think my talk has 6 slides. That's more. So I come to you. What was your name?
Brandon.
Brandon. So let's say I come to you and I say I have an AI and I can fully interpret what it's doing. So are you satisfied with that statement?
No, I want to know more about
How
we interpret.
yeah. Maybe you can interpret it, but you realize that actually it gives you low accuracy prediction. So you know how it's doing it, but it's not useful. Or maybe you realize, so there is this classical example, I don't think I have it on this slide. So some of the early years of AI, they went to take, let's imagine it was MRI scans of patients that they were diagnosed with tumors, and scans of patients that they didn't have a tumor. So they train an AI to do that prediction. and it was doing very, very well to do this task of diagnostics and the predictions on the test on these sets of data and images that they had. But as soon as I took it to another hospital, like it was as if it was doing a random prediction, so it drastically failed. So, and they went to take a closer look, and they see something interesting. They realize they had so when you take, I think you probably know more, so when you take this medical imaging, there are some like identifiable markers toward the top right of these images. So what happened was the portion of those images that had tumor from patients, they had some markers. And the images that were from healthy people, they didn't. So what the AI system it looked to try to classify and to predict was not really looking to characteristics of biomarkers or where the tumor is. It only looked into the right top, like is there a marker in the top or not? And of course it drastically did well. So this is an exaggeration, although it was not an exaggeration, but it's an example to tell you that they may do well, but they may rely on characteristics that are not really those that you as a human will look for. So it's important for them, maybe if you want to think about it technically, to look into that causal relation. From, like, there is a tumor, there is this shape, so this is why this person has a tumor. So you're going to look into that region. So, and this brings us to this notion. So now I'm showing that very same example for a classifications of husky. So my network, imagine that I give this image and it classifies my husky as a wolf. And I tell it, why did you do that? And with all these tools, it tells me, oh, it's easy. I look at the snow. So, because all the wolves are usually in snowy places and snowy backgrounds, so it constructed this spurious correlation. So again, slightly simple examples, but when problems become more complicated, these AI frameworks rely on these spurious correlations. So it's not really looking to characteristics. Maybe it should look into how the nose looks like, how the eyes look like. It looks into the easiest feature. So it looks into what's in the background. And in healthcare, you don't want your AI system to have that. So this is called spurious correlation. I think there is a website actually that they try to make this funny spurious correlation of, like for example, number of sunny days in a city relates to like number of people that do suicide. Like it's like very, very random. Actually, maybe that one was slightly correlated, so I had to make another example. But like very, very random phenomena and features you can try to relate, but they're spurious, not related. So AI frameworks does that, and they also do one more thing, which is related to the world model I told you about. So ideally speaking, if you want to use an AI that it's going to tell you something about your world, your scientific experiments, the human body, maybe you look at the cell level in chemistry, you want it to have captured that underlying physical laws properly. So this is an example of actually from a real foundation model. So these models, the ChatGPT that have got larger and larger, they're being called foundation model. It can do a perfect prediction of how the Earth is predicting over the sun. But when you start to interpret it, to see actually if it can show you the force, this true force that goes from the planet to the sun, so this is where they're turning. I actually had to ask your background in physics before providing this example. But let's imagine that we know that there is this a point, a vector of gravity that is moving you toward toward the sun. So it gave you these random vectors as a PNQC. So, and probably if a physicist were to try to use these AI frameworks to discover the worlds of the new rules of space and maybe at large scale for astronomy, I'm going to tell them, please don't. It's giving you wrong. It's giving you a wrong understanding. So we're not there yet. So it's basically, we thought we were going to come talk about all the goods and accuracies and how AI is transforming. You're surprised? No, I'm a person that talks about why AI, because I need funding, right? No, that was a joke. Okay. Hopefully, we kind of convince you that we need to interpret them. But when we interpret them, we realize that they actually rely on wrong things. So this brings us to another statement. So I'm doing this post hoc interpretability, and I realize they're not working. And Brandon said I need to know more, and I'm going to characterize it in a way that let's have models that are inherently interpretable. And what I mean by that, they rely on not spurious features. They rely on those features that we as humans also rely on. If a doctor were to look at a CT scan and is trying to diagnose, then what they're looking for. So we should go for those explanations that rely on at least human aligned features. Okay, so this brings us to these notions. So maybe we only go through one of them. We don't have to actually cover all these slides that I do have here, because so I want to actually for us to have more conversation. But so next time you actually talk to a AI person, so tell them you know about interpretability, such that you can either interpret them. You're sitting as someone that maybe haven't really created those AIs, but you want to see how they're doing, mechanistic interpretability, you understanding the AI, or you want to have an AI that is grounded in reality, such that the AI is aligned with you as a human and with the physical world. We probably want both of them, but I may want to argue that we need these more. So maybe if you don't want to interpret them, at least it's something that we should rely on. Okay, so but before we actually move to that one that we know more, so let's actually do a few abstractions. So is there any questions? So maybe I should ask this. So which one of these you'd like to know more? First one or second one? Second one. So then let's go through like maybe 10 minutes on the first one, and then we move to the second one. Okay. All right. So I have that gigantic AI now. We don't know what it is, so let's see if we can think about it, that it has captured something about our data. So, and let's say for simplicity, because I don't know the terms in healthcare, so let's say that we are actually living in some computer vision examples, that the images that you're giving to your AI framework, for example, maybe there are some cats appearing in your images, there are cars, tables. So if you want to look into medical imaging, so then there can be different forms of maybe cells and those domain knowledges. But to make it simpler, let's think about, we have 3 concepts that appear in our data. So I call them concepts. So we probably have a lot of concepts. So you can, if you want to count these semantic informations, they're bottle water, they're mobile, chairs, that there are many concepts. This is probably why AI frameworks are getting larger and larger, because they want to make sure they can capture all of these. But there's something that has happened in our AI frameworks, which is as following. Because the scale of our neural networks, or AI, are smaller than the complexity of these concepts that exist in our data, the AI frameworks are trying to represent them in an entangled way. So what do I mean by that? We don't actually have a board here to show you. So think about it that if your AI, so I'm calling it neural networks, had capacity of 2. So this is a toy example. And if it wanted to represent these 3 concepts, so maybe it would have assigned cat to the first one, car to the second one, and the first one, and table to the third one. So it kind of has to combine all these concepts within itself. This is an abstraction that I'm talking just to say that why actually it's hard to understand what's going on inside of these networks. So, but because we know linear algebra, because actually we know math and we know about all these concepts of how information moves. So machine learning engineers have come to be able to use an approach to basically move from here to here. So they said, I'm going to look into representations of my data and disentangle them to be these concepts, such that then you, as a medical practitioner, you don't need to really look into the AI. They're going to give you maybe a set of vectors to take a look which of these concepts are existing in my MRI that I have from my patient. So, so this basically, so we're not going to cover this. So this basically then talk about notion of, if you were to talk about different concepts, which are each of these lines, so how I'm going to represent cat, how I'm going to represent the other feature, how I'm going to represent, and they come up with some theories that it's not important for us here. It's for completeness. So any question about these abstractions or why it's actually hard to have this? So, and then they use these concepts. So here we are looking at it from perspective of the language model. So if you were to have a language model, they were to take these activations that are inside these models, and they basically, so these are, you can imagine, were combinations of cats and cars and tables, and then they basically transform it into some other representations that are much less active, and you should be able to refer to them. For example, if you were to take a look into some of those concepts, it tells you that it is referred to chemistry terms, and then it is referred to some meaning of whenever I do this analysis, it's telling me that there is an ing in my sentences. So in terms of the medical imaging, you can thinking about it, you can have this code dictionary of these human understandable cookbook that you pass your images to the model, and then you use this technique, and it's going to tell you what are these concepts that are up here. If it's going to rely on ing to tell you that like sun has some properties, then you may say that you're referring to ing when making a statement about sun, which is not what you're relying on. Okay, so are we done? No, we want to go to the second part. So any thoughts, like how do you think about interpretability? So let's say so far I just used the word a lot. So like how do you all, when you hear this word, what do you think about? So what does interpretability mean to you?
think like understanding.
Understand
Like translation or something.
translation. So, and let's say if you were to use that AI, what? It tells you something. So maybe it tells you that maybe it's gonna tell you the probability of this person actually committing a crime is very high. Or the probability of this person going to be diagnosed with a particular disease that 20 years you were talking about. So it may tell you in the next 5 or 10 years this person is going to get a particular cancer. So, and what are the questions that come to you? So you can't really just have a conversation, easy conversation with that AI. So you may want to know, like what are the things, if the AI would be able to talk, what were you asking after this question? So I'm an AI. So I'm telling you that this patient probably going to get cancer in next 5 or 10 years. And you should trust me. I'm not gonna say another word, but what is it you want to know from me?
Probably like why, and even if you get it, like how to treat it.
Or how we can prevent it. Like if we know what's going to happen in 5 years, is there something we can do to prevent it, or at least stall it even longer?
Okay, so yes, these are all the questions that should give us. So this basically brings us back to first, okay, how did you do that? Why this is? And then trying us to understand, maybe it's going to look into the patterns of things that this person has done and telling you, I basically tell you this decision based on these patterns. So when I were to show you this like very abstract dictionary, I'm showing these tools that if you were to search, for example, like the notion of autoencoders, are it's the tool that people are using to get that sort of why you are giving me that decision. It's a hard question to talk about prevention, but depending on what answer it gave you, so it will probably require experts to come and like comment and then combine it. But the reason that someone is going to get probably tell you also what you shouldn't do, because it's telling you what you have been doing so far, and you may try to actually decrease those. Okay. All right. So let me actually pass this section. So because we're gonna reach to the second one. All right. So now we're in the stage we did not satisfy with your explanation because you're giving me explanation that doesn't make sense. You look into the color of you look into some brightness of my images and told me something about characteristics of these cells that existed in my data. So the brightness of an image shouldn't be a predictive feature. So this is what I'm calling it. Ideally, we want AI to be aligned with you, to be aligned with the world. So before that, so last time I was here, I tried to actually went through a few, indeed 4 key terms that they probably have heard about, all of them, but maybe not in the same place, that we need at least some of these properties so that AI can become easily applicable to high stakes applications and something that probably we can use in more real world settings. So I'm calling them systems that are useful and let's say useful for science. So useful for healthcare and science. So what are they? Okay, so probably first thing people we want them to perform well. So we want them to be reliable. So if you were to move it from one hospital to another, it shouldn't give you another answer. This is notion of generalized. So you want them to generalize such that they're not going to be limited. This one that today we are focusing on, so which is more related to the first part. So we want them to give us how they reason. So the reasoning to be transparent, how these decisions are being made, and what are these key factors that you gave me your decision. So interpretability literature, look into that. But we're not going to stop here, so now we're going to briefly take a look into the second interpretability, which I'm referring to it, models that are grounded in reality. So indeed, if you were to talk to machine learning people, they get to also use many different words for these. So if I want to think about it from more scientific data perspective, you can think about it, our world is causal, and there are basically, like if there are some underlying causal physical, biological processes that govern my data, you want to make sure that the AI reflects that. And collaborative, why do we need it to be collaborative? At the end of the day, there are going to be users using. So you want to make sure that they take inputs. They're going to be human in the loop, but if they're going to be changed in your criteria, you can easily tell it to reflect. So remember these key points. So, okay, so now maybe you're walking on the street and you're going to see someone that recently joined OpenAI, hypothetically. And you're going to, and this person probably going to tell you, oh, it just came from this presentation that they were all talking about interpretability, like reliability. No, you don't need that. Like just we have a lot of data. You use the data and train it until it gives you the performance. So is the data the solution? And wait until your data, your network is trained. So they themselves have indeed finally, this is a sentence from some of our machine learning experts in industry. So they said the age of scaling is over. So what do they mean by that? They actually, the data is, the amount of data they could actually use to train ChatGPT, they're done. So we don't have much data. So if you actually nowadays go work with ChatGPTs, you're probably generating data for them to make their networks better. So now they realize that we do still have problems. This AI framework is still maybe too complex to understand. They're not performing well. So maybe we can go and focus on what Bahareh is saying here and see how we can improve that. Okay, and to actually support that the age of scaling is over, and aside from the applications, so let me show you two figures here. So there has been shown that, imagine that this model that is interpretable and is grounded in reality is red, and the model that is not grounded in reality and only wants to take a look into the data is the blue dashed line. So the curve here shows that even if you were to look into infinite amount of data, the model that maybe is grounded in reality perform better. Or if you were to have a fixed amount of data, the model that is going to perform better with the same amount of data is the one that you maybe incorporated some of these things that we know about our world. So, and I'm referring to them as structured models. So what we mean by that, a model that maybe it doesn't only rely on data. And there's two other curves at the right, and it actually shows something interesting. So they went to do a project, so I think a lot of this data now is analyzed at Stanford, that they had this baby view camera, they put on babies, and they were collecting what they're seeing. So we as humans seem to learn very efficiently. And the question is, if we were to feed the same amount of data that we are seeing to an AI, can they generalize as we generalize, and can we perform? So the top curve showing that, so this line is actually the interpolations, and if you were to go all the way to a lot of data. So if you were to reach a human performance for categorizations of objects, we're going to need 10 to the 7 hours of video. So with our current technologies. Is it a million? 10 million? 10 million. So we need a lot of years. Like probably not to the age of like even if you were to maybe be alive for 200 years, it's still not enough. So and then another one is that even for some other tasks, they are not. So hopefully this figure actually convince you that we need some form of models that are not only relying on data and something that is grounded in reality. So let me go through 2 more slides and then we can go for a question. So I want to argue that we probably have a way to do this, to achieve an AI that can generalize. And we don't need to go far, so we probably need to think about how we as human analyze data. So if you want to do a scientific, if you're in science, if you're a scientist, what do we do in science? So we get data, we observe, we perform some modeling, so you form some hypothesis, so you're thinking, and then we try to actually infer some certain things, but after your modeling, you analyze, and then hopefully those results, you want them to be generalized, such that the statement you made about how these cells should interact, hopefully if you go 20 years from now, so that rule that you have identified is still going to be there. So observe, model, infer, and then generalize. So now that we have AI, what has happened? So we still get data, so there is observation. We have some modeling. Before the era of AI, so we have technology that can actually try to model for us, and then we are doing this role of inferring and generalizing. So we are responsible as biological intelligence system to understand and do those discovery of principles. So what's actually the problem, in my opinion, in current AI system is that we try to replace all these 3 steps with an AI, but we never tell the AI that you actually need to do both modeling and inferring and generalizing. They're not really doing any inference. They're not really understanding what they're doing. So, and the solution can be, have you seen this? Bloom's taxonomy. So the solution is, so a lot of AI frameworks remember, a lot of them maybe understand. So if we can push them more to the higher levels of the Bloom's taxonomy in the way they're being designed and interpreted, hopefully they can perform better. Okay, so I think I want to leave time for questions. We have 10 minutes left. 10 minutes.
Yeah, like 15 or 20.
Okay,
Yeah.
okay. So then maybe we can keep going. So how do you think? What do you think is the solution? So we want a framework that we want to design that interpretable AI I told you about. So I didn't forget we're going to get there. And going to here, we want an AI system. So AI is automating all these 3 tasks because we feed them the data and then we tell it just, I'm not going to look how you're doing that, just give me the answer. So there is a solution. So we're going to go through it. So are you ready? Okay. So AI are called neural networks. Right? So why are they called neural networks? Does anyone know why they're called neural networks?
Because that's the way our brain works.
Yes and no. Yes, that's the question. So they are actually. So let's go through all the way back. So let's think about those 2012 networks that everyone's in AI started talking about it. So they are inspired by how our early layers or how our visual system is working. So it was primarily focusing on those. So if you were to actually look into some building blocks of these AI systems, so they actually act like how neurons have a nonlinearity that they don't fire, and after some point they start to firing. So they have that type of model. So this is what called their neural networks. So, however, they are not truly works the way our brain works. So, and I think the solution is into here. So, if we were to design neural networks such that maybe they can form hypotheses about the world and process information based on that, they can do it better. So anyone knows probability here? No? So, okay, a little bit. So let's skip through this probability because I think if you don't know about that, it doesn't make sense to go through it. But I'm going to talk about that probability in a visual way. So how our brain works. So maybe we should have them to design in a way that the brain works. So there are computational neuroscientists based on the probability that I showed that they say that we do have some hypotheses about how the world looks like, and there has been experiments to show that the responses that we get here, they try to somehow, this is an abstract way of comparing the representations in our brain to what we are expecting, and if there is a misalignment between them, they try to correct. So they try to go through an internal world model to do the computation. And it has been shown in the literature that if you actually were to do these things, the networks start to maybe be more robust, generalize better, to be interpret better, and such. So this is related to there is a brain hypothesis that computational neuroscientists thinking about how the brain represent data. Okay, so questions. So enough of me. I think this slide probably was a little bit abstract, but so. What probably you need to get from here is that there should be some comparison of things you're expecting and to be a recurrent connections in these AIs that you're having such that they compare what they thinking they're seeing to what they're seeing, and then if they're not aligned for you to compute it. Or maybe you can go and if you're in biology and you know actually certain understanding of your data, so you can incorporate it. So this is called, for example, physics informed or some of those ideas.
Is in this slide, is the world model, that would be like what we're expecting to happen, and then the other model would be what we actually see, and then we compare those.
Yes,
compare those two?
exactly.
Yeah.
So you need to form a hypothesis, like what am I expecting to happen, what am I expecting to see, and you keep comparing that. So you may ask why we need that. So you can imagine that if I were to turn off the lights and you get to see a very blurry face of me, because you're expecting that there is a human standing here, so you can probably have a better perception because you're expecting me to be there. You know how a human looks like. So if you have an AI system that has not that form of reasoning. So they may not be able to, in a darkness, all of a sudden, because all they see was in light, and when you turn off the lights, it may drastically fail. Okay, so I'm going to pass this one. So these ideas then has come here. So for example, so we talked about communicating with a world model, and there has work that's showing that if you actually were to have these recurrences of communication, you will be able to have a network that is more aligned, and you will be able to increase some of those robustness properties that they may have. So they take one of these AI frameworks, and the only thing that they need was to rewire some of the internals of those for improvement. So why am I sharing in this? Because so when you were to maybe try to use AI in your work, they're not just going to be one. There are billions of them, there are millions of them. So it may give you a bit of understanding of which one of them I may want to rely on and which one I want to use. Of course, it requires a deeper discussion, but this is a few. So this idea of internal world models. So if you just want to know what I'm really talking about, so there was this recent work that they show if you were to actually have this recurrency of reasoning, you should be able to have an LLM that is much, much smaller. So, and they're calling it tiny networks. So that idea came. So maybe this is just that recurrency is one example to thinking about maybe in order to improve AI, I should thinking about how I think, because there is a biological network here, and I should make sure that they do at least reason in the way human are doing. Okay, so I told you 2 slides, but actually it got more. I thought there were only 2 slides left, but let's go through this. So I mentioned to reach interpretability, we need some recurrence and we need some internal models. And a lot of time we do actually have those internal models that we can incorporate it in our network. So here I'm bringing some examples that I had worked on before. So let's say I'm an engineer, I told you about that. If you want to, for example, analyze data of detecting targets in space, so engineers have previously modeled that, so you can incorporate that model and allow you to generalize with much less amount of data. And it helps you to have more efficient architectures, we told that in the previous one, but it helps you to also make reasoning and understanding in computational neuroscience. How? So let's go through an example together. So let's say that you're a neuroscientist and you're doing an experiment. You have an experiment set up, so the mice is actually moving around, and it's there are the variety of things it can interact with. And then as this is moving, so there are going to be some neural responses that we are recording from the brain. And as a neuroscientist, you were to have these spiking activities, and what you're interested is, of course, you don't have access to exactly what's going on inside the brain, and you want to understand what is the relation between what I have measured to these maybe stimuli that have stimulated the brain. So without actually having an AI, so neuroscientists have went and created a model that goes from these causes to the measurements. And if you incorporate that internal model with the AI framework, it can, for example, does the following. So we can have a variety of spiking activities, and here there are dopamine neurons that if you were to give them more water, they're going to be fire more. And you can break down these into some understandable representations that, for example, I'm showing here, with some of those recurrency that I talked about, so that, for example, it can tell you about the type of the experiments the neurons have and how much, for example, water have been given to the animal. Or we can use these ideas to try to, for example, form hypotheses about what's happening inside the brain by looking into these representations that we could get from the first part of the talk, from mechanistic interpretability, to tell you what are the key aspects that are in the dorsal or ventral strata. Useful interpretability that comes for scientific purposes. So I didn't go through how we did it, but the AI was designed such that it could do that recurrency and the brain hypothesis that I mentioned earlier. Okay, so I want to open up for questions. So is there any question, any thoughts?
Do you think that the next leap will be AIs that can build like more accurate world models rather than AIs that are just predictive, predicting the next token?
So there are some active research are trying to understand that internal world model. So so the next step is to improving that. So because they're doing better next token predictions and all these things. That example of the planet was a real example, such that it's very clear that they have not captured that underlying understanding. So there are other examples that for example, I can bring another example that they try to show if an LLM can form hypotheses and answer these hypotheses in the scientific setting and such. So they're not good at rejecting hypotheses or like maybe they're good at forming and some of the ordinary things, but there's still a long way for us to be able to reliably use it. So, and in my opinion, to be able to address these things, we need to understand where their limitations come from. That's why the interpretability matter. And after understanding, so maybe the engineers and scientists to thinking about how we can even improve it.
What do you think about mulch bots? And isn't it just a natural evolution? If there were going to be AI agents, then there would eventually be social media for AI agents. And it makes sense that we could witness it, but we couldn't actually take part because we're not AIs. Or is it the most frightening thing you ever heard of?
Well, it's frightening. It's very frightening, but I should probably say the following. So what is the goal? What is the purpose of that AI? And what's our purpose? So if they were to interact with each other, what would be that thing they might be planning to do?
Well,
so it's frightening.
Don't you think with the human beings in the room, these are fairly normal people, we don't really have a well-defined purpose, right? I mean, it would be boring if we did, because it makes us much simpler than we are, right? We're nuanced, right? That's what's cool about us, is we're nuanced, right? So that would mean by definition, it would be cool if both the AI agent didn't have a specific purpose, and if we don't have a specific purpose, but when it's on a specific task, then it can have a specific purpose to complete the task, just like we can, right? We are this wonderfully complex being capable of all sorts of potential things, but at a particular time we're trying to do something. And if we want to take a trip to Spain rather than us organizing it and trying to figure out which beaches to go to and so on. We can get the AI to do it, and it's practically free. Now, that's the other thing, that a lot of the people that I talk to about this, they have this cash register in their mind. I thought this was a thing that only physicians do, that they think, am I making money, am I making money? But they're always thinking like this, and they suspect that everybody else thinks like that too. So they can't believe in an abundance future. That makes no sense, that you'd be able to have things for free and be able to do whatever you want, and virtual reality is better than real and shareable with friends. That's just crazy, because the ka-chung of the cash register isn't built in, you know. So how do you feel about that? Do you walk around thinking of human interaction always that ka-chung making money? Or?
Well, probably then we should be frightened more by our interactions with humans.
Yes.
Than the AI.
Yeah. So you know, the strange thing about me, this is really true. Since July 1st, 2022, I record the CBC Radio 1 news at either 3 a.m., 4 a.m., or 5 a.m. every morning to see how human cooperation's working. And if you think about it, that's not good enough, because the stories don't resolve. So you always want something like the NBC news for kids, because there, the only stories that they tell always resolve. So the kids, oh, isn't that nice?
Yeah, we are biased toward hearing good things that
Yeah.
we like to hear.
Yeah,
So
yeah.
that it's simpler to understand and save
Right.
time.
Right.
So.
But I think, honestly, what the news tells me when I listen to it every morning is that human beings cannot and should not be in charge of the world in the future. They're incapable of it, and AI is capable of it and can do it on our behalf. And that's what Rich Sutton and I have both been talking about since 2016. And so, and yeah.
But going back, excuse me, going back to the whole like thinking about cash registering money, everything that you were talking about requires money. So going on a trip to Spain, if you wanted to do it spontaneously, at the end of the day, it requires a certain amount of money.
Now, yeah, but we're heading toward a world like one of the things that I'm most exciting in my life, when I talk about AI agents, there's always somebody there who's actually personally planning to make profit on AI agents. And when I suggest that the cost of AI agents is going to come back down to practically free, they get so angry, because their whole plan for the future is to insert something where they personally make money when you use an AI agent. But I think it's not just AI agents that are going to get cheaper. Everything's going to get cheaper. That's what, you know, abundance means, right? And so we won't need money. And I know most of you can't imagine a world without money, but that's what's going to happen. Actually, what would interest you, when Rich Sutton and I first talked about this, he sort of stiffened, said, well, I think they'll still have money. Rich, what? In India, there's this, you know, community where they haven't used money for years. And so I went there, and it seemed like kind of a nice place. But immediately after I left, there was a brutal murder there. So it's not necessarily an ideal society, but it exists even now. People can have a barter kind of system where you don't need money, and it's kind of nice and civilized. Yeah. So, but our the young people of today incapable of imagining that that could actually work?
I think that, can I
Yeah.
argue? Okay, I think that, so right now, when we're thinking of like, let's say for example, like the electric cars, like the Tesla, it's really expensive right now, right? But in the future, when electric cars become like a normal thing, yeah, it's gonna go down in value. Same thing with AI. AI is very like ChatGPT, it's all very new, it's a lot of AI related things, it's very expensive, it's very high in value, but as soon as it becomes more normalized and more easily accessible, it's going to go down in value. So it's going to become cheaper because it's going to be more accessible. So
Right.
as soon as something's newer,
Right.
it's going to be higher in value.
Right. So to all of you, money is a real thing.
Yeah.
But money is really a fiction,
It
right?
is, yeah.
It only works because it's a shared fiction that we all accept. It's a useful fiction for us, but money doesn't, intrinsically.
I think money is a fiction, but value is not a fiction.
No.
So it's
Right.
money is the thing that we use to transmit value from one thing to
Right.
to another. So.
So
I
what
think there'll still
will
be value
be-
in the future. Maybe it
what
won't be
will
money,
be
but
the
we'll have
value-
transactions.
Of the future. And I would argue that, like we talk about artificial intelligence now, artificial purpose will be an important value. You want to be able to play a game as if you were going to make money, or as if, and have fun, because you're engaging in the fantasy that you have this purpose, right? So it's hard to imagine future life without that, right? But if you accept that, then you can spend your days as you would most like to spend them, hanging out with the people you most enjoy hanging out with, friends and family and stuff.
All your favorite agents.
Yeah, yes. And engage in pleasurable activities with them that only make sense if you have this artificial purpose. Let us pretend that on the holodeck that it matters, when we sword fight who wins, and we'll keep score, and yeah. So, and I think getting artificial purpose right is important as making money, because it becomes sort of the substitute for it. If we don't really need money in the future, we still need purpose. Yeah. And interestingly, Nick Bostrom, who wrote Superintelligence in 2014, and then this book about Utopia in 2024, the interesting thing about him, he doesn't teach. This is possible in the UK system, that you have a bright researcher and they just do research and write papers, but he doesn't actually teach people. So I think that's why his book, Deep Utopia, doesn't really satisfy you. So, and I think what it's missing is this artificial purpose. And I think he can't get that because he doesn't teach young people. Like, the odd thing about my career, surrounding myself with young people the past 54 years. If I wanted to talk to somebody, there was no other option. I don't have anybody my own age to talk to. The only human interaction possible is with people like this, yeah. And it's turned out pretty well. I didn't do it for that reason. It isn't like strategic that way back in 1973, I didn't decide to do it because it would keep me young or something, but it did, So anyway, so I think there are things like that. If we say that this course has survival value, when the future comes, you guys will understand it better than others, because we've talked about scenarios. Some of them will happen, some of them won't. But when the ones that actually do happen, you'll be more prepared, right? It's sort of like what I've been doing by constantly interacting with young people from 1973 to now. It sort of keeps me relevant, right? And gives me faith in the human species, right? Like, take somebody who believes strongly, as many people do, you should only hang out with people your own age, right? Everybody else is an idiot except people your own age, right? And therefore talking to people who are not your own age is a complete waste of time. Yeah, they're really missing something. And so during my career, I sort of got what they're missing. And every time that they suggest that, young people aren't worth time, practically every bright idea I ever had ultimately came from my interaction with young people. So it's just cool that this is my superpower and my only one, right? I got it from you guys.
It's new knowledge, right?
Yeah.
New knowledge from younger generations.
Yeah. And you can have fun with it. Like the students who take this course, back in the day when there were popular radio stations for young people, none of the students who took the course listened to those radio stations because their cerebral life is much higher than that. So I knew about the new popular songs for young people before they did. That was cool. Yeah. Anyway, thank you for teaching us.
Thank you.
And we look forward to you coming back again and again. Yeah.
Thank you for having me. So hopefully next time will be more figures.
Yeah. Okay.